Precision3D Hydrology. Video number 25 deals with three special topics. The peak flow time of concentration method. We haven't yet discussed the hydro method. Culvert HY8 method for culvert design. And also the whole issue of undersized culvert pipes, which lead to this telltale circle, yellow circle, meaning the pipe is too small, you're overflowing your maximum headwater line. So let's drop into P3D, and let's start with the latter topic first. Here we have a culvert that's been designed. We'll notice if we slide over here, and we're going to do one more thing, we're going to make sure we unlock our storm. We just loaded this P3D stored scene, and we notice that we have a time of concentration of 4.9 minutes on this site and a peak flow of 25 CFS. About 5 minutes, a time of concentration, 25 CFS. And that 25 CFS leads to an undersized pipe here. And the way you can change that is click on the pipe in question and then select not the auto calculation mode, which is the calc pipe size option, but drop down to calc or go up to calc headwater. And with calc headwater selected, you can change just underneath there the pipe diameter to maybe the next one up to see if it works. When we go to 24 inches, we can see now that the headwater draws at the elevation appropriate to that amount of peak flow, given the larger pipe size. So that's how you resolve those yellow circles of overtopping headwater. You increase your pipe size. The next issue we'll look at is the time of concentration method. Right now we're using, if you click on the storm event, we're using the TR55 kinematic wave. This is preferred by, for example, Kentucky Transportation Cabinet. We can switch it over to the hydro method. When we select that and you hover over that method, you can actually see the formula involved. And it has very few elements to it: flow length, average watershed land slope, and the average runoff coefficient. So this is a simple formula. And this one does not factor in the telltale sheet flow, shallow concentrated flow, and channel flow of the TR55 methods. So when we recalculate, watch for a different appearance of our longest flow line. We'll recalculate the storm event and pause while we do. Let's actually resume and zoom in a little bit to see if there's any effect on the headwater line produced. And there certainly is. It actually dropped down. We have lower headwater under these circumstances, and we notice that the time of concentration has slowed way down, which is why we have less peak flow. It's slowed way down to 22 minutes by the hydro method, and the peak flow is down to 14.7 CFS. So it's actually possible, if we are computing by the hydro method, that our original 18-inch pipe might work. Let's try that. How would you make that change? We're still in calculate headwater mode, so we can change it back to 18. And 18 actually works by the hydro method. The hydro method obviously is less conservative than the TR55 kinematic wave sheet flow method that we were using earlier. Now, there's one more thing we can look at here, and that is any changes whatsoever in designing our culvert by the optional method. The culvert itself can be modeled by inlet control, outlet control. Optimum finds the most conservative of those. But HY8 method, also currently adopted by many of the DOTs around the United States, may have some effect here. Let's see if the headwater line bumps up or down as we switch methods. We probably have to recalculate on the fly, or else it had no effect whatsoever. It's very marginal effect. Let's find out. Let's see if there is any effect when we recalculate. And we'll pause while we do. Okay, we're resuming. And just the ever so slight change, very little. In some cases, the effect is more noticeable, but here the HY8 is very similar to the previously controlling inlet or outlet control.